what happen? Br radical either can go to middle carbon or terminal carbon. If it goes to terminal carbon, possible? If it goes to middle carbon, correct? This is secondary, so it is stable, so it is major. This becomes minor, right? So these radicals again combine with peroxide. From here, H radical is taken. So what you will get? CH3, CH2, CH2Br. And what is left? OOH radical. Right? Response, sir. So I am not bothered about the other products. So this will be major. Negative part means Br is going to less substituted carbon. So what we got as anti-Marconi half product. Correct? So directly I am writing here. I will get two possible products. One is CH3, CHBr, CH3 plus CH3, CH2, CH2Br. Now which is major, sir? N propyl bromide is major. Correct? So this is major product. Anti-Marconi half product is major. Karash effect is not observed in case of HCl, HF and HI. In these three cases, no peroxide effect. Correct? As there is no peroxide effect, which is major. Therefore, Marconi half product is major. Correct? Now, here as there is carbocation formation, can I say here carbocation rearrangement may occur? Respond. Now, rate of reaction can depends upon stability of carbocation. Respond, sir. Let me show that class 11th notes once. I will briefly show it and I will come back. Hydrocarbons. Carbons H only, no? No. Alkenes topic. Hydrohalogenation, addition reactions. Addition of HX to alkene is called hydrohalogenation. Same example we have taken. Marconi half product, anti-Marconi half product. What is Marconi half product means? Negative part of the added reagent goes to more substituted carbon. Now, HBr. Now you have got one carbocation. Now carbocation can undergo rearrangement. This hydrogen migrates here to form tertiary. So tertiary becomes major. That's why in case of carbocations, rearrangement is possible. That's why here this becomes major. Correct or not? Next, radical mechanism. peroxide effect or Karash effect or anti-Marconi half product is major. No. In case of HCl, HF and HI, peroxide effect is not observed. Reason? In first step, you got peroxide radical, means RO radical, forms Cl radical. This is endothermic reaction. Similarly, in presence of HF also, it is endothermic reaction. As this step is endothermic reaction, I need to provide a lot of energy, right? Therefore, this reaction is not favorable and hence it doesn't occur. So that's why Karash effect fails in case of HF and HCl. Now, in case of HI, this bond can break easily. So this is exothermic only. Similar in case of HBr also, it is exothermic. Means first step, formation of Br radical or I radical is favorable. Next step, I radical has to attack on alkene to form alkyl radical. This became endothermic if it is iodine. But if it is bromine, exothermic. So as this step is endothermic, this reaction is not favored. This is the reason why in case of HF, HCl and HI, peroxide effect or Karash effect failed. Respond, sir. Respond. Any questions in it? Same thing I have written. Yes, sir. So
no doubts.
Here what I will write? In case of HCl and HF, formation of halogen radical step is endothermic. Means can I write here? Shall I write like this? RO radical with the HX forming ROH plus X radical. Now, in this case, in case of HI, which step is endothermic? I radical attack on RCH double bond CH2 to form RCH radical plus CH2I. Correct, sir? Respond, sir. These two steps are endothermic steps. As those two steps are endothermic steps, reactions will not occur. Will you understand if I simply write in that way? Done now. So this is example of hydrohalogenation. Whether you are able to get alkyl halides from alkenes, right? Next one, sir. Halogenation. This is hydrohalogenation. Next step is halogenation. Means alkenes react with X2, right? Particularly, directly can I take example instead of writing that words? Directly, I'm taking one example. CH3, CH double bond, CH2 I have taken. Allowed to react with chlorine in presence of sunlight. What happens? Chlorine in presence of sunlight or on strong heating or N-bromosuccinamide or NCS. In all these cases, allylic substitution happens. Not addition reaction. If the same chlorine, I will write this in this way. If it is allowed to react with bromine in presence of CCl4 or chlorine in presence of CCl4, now it is electrophilic addition. Or Br plus will come and attack now. Or we are talking about what? Electrophilic addition reactions, na? Respond. Now what happened here? First Br plus will go and attack, forming CH3, CH, CH2, Br, partial bond, partial bond, partial bond, positive charge. So we got a 3-membered cyclic transition state. No carbocation formation. 3-membered cyclic transition state. Then Br minus will go and attack. Right? Now Br minus can attack either here or here. Which is preferred? Attack here is preferred because here partial charge is more stable. Because here if you get positive charge, secondary carbocation. Here if you get positive charge, primary carbocation. That's why here it is preferable. So Br minus preferably attack there, forming the product CH3, CH, Br, and this CH2 goes below. Now both bromines are added in opposite direction. That's why it is an example of anti-addition. Correct? Right. So here we need to remember one more thing. Cis anti-addition leads to formation of racemic mixture. Correct, sir? If it is cis alkene, if you do anti-addition, then it leads to formation of racemic mixture. If it is a trans alkene, anti-addition leads to formation of meso product. Respond? Okay, well, here also we are getting alkyl halides, of course, dihalo derivatives I got. Right? Same way, instead of bromine and CCl4, if I add any other reagent like acetic acid or H2O or methanol, then what happens? One Br plus will attack. Instead of Br minus, H2O will donate lone pair, or methanol will donate lone pair, or acetic acid will donate lone pair. Right? So I am taking one more example. Same CH3, CH, CH2 in presence of Br2 and H2O. Solvent. Polar protic solvent. Here a protic solvent. Here polar protic solvent. Now, first step is as it is. Formation of 3-membered cyclic transition state is as it is. So I am copying this as it is. But here instead of Br minus, I will add OH. Correct, sir? H2O will donate lone pair of electrons, making this bond to open up. Then what you will get? CH3, CH, OH2 plus CH2Br. In next step, from here H plus will be gone, forming CH3, CHOH, CH2Br. Correct, sir? So it is an example of halohydroxylation. One halogen is there, one hydroxyl group is there. So that's why it is called as halohydroxylation. Response, sir? Any questions, sir? Right? So here you got halogen only, but along with halogen, I got OH group also. Instead of H2, if I add methanol, you will get OCH3 here. Response, sir? If I add acetic acid, I will get OCOCH3 group there. Correct or not? I will show the same thing here. Observe this reaction. Electrophilic addition via cyclic transition state. First Br in terms of CCl4. Response, sir? Now same Br in terms of CCl4. What I have taken here in next case. If I have added water directly, I will get alcohol. If I am taking bromine and water, then you will get OH and Br both. Response, sir. Any questions? No sales. Here, then it becomes minor. And we are talking about major products only, na? Here you get more positive charge, therefore stable. That's why I'm doing that here. You can change it, but that becomes minor product. We are talking about major products. Clear? Any other questions? Now see this one. Allylic or benzylic substitution. Stop talking. Allylic or benzylic substitution. Now see this, sir. Same. Stop that, man. CH3, CH double bond CH2. Allowed to react with NBS. What is this NBS? N-bromosuccinamide. This also prefers free radical, right? But it is an example of radical substitution, right? Pr radical will go and attack on allylic position because allylic radicals are stable, correct? So first you will get CH2 radical, CH double bond CH2. First you will get that radical. This radical can undergo rearrangement also. This bond will be shifted here. You will get CH2 double bond CH single bond CH2 radical. There is no difference between both. Correct or not? This pi bond got shifted to this side, you got radical that side. Or this pi bond undergo homolytic cleavage. One radical there, one radical there. Between these two radicals, bond formation. Right? So radical rearrangement may occur. Because of pi bond. Now lead to formation of. You get CH2Br, CH double bond CH2. Similarly, on benzene also you'll get Pr radical on that. Yes. Wherever you keep, you'll get same product. Because of rearrangement, stability enhances. Correct or not? So radical became more stable. Anyhow, we are getting same product. Stability of radical got enhanced. If it is a different one, for example, if it is CH3 bond CH double bond CH single bond CH3, if this is allowed to react with NBS, now so you can remove either here or here. So I am writing CH2 radical single bond CH double bond CH single bond CH3, one possibility. Now it can undergo rearrangement. Then what you got? CH2 double bond CH single bond CH radical CH3. This is primary radical, this is secondary radical, which is more stable. Therefore, this leads to product that is major. This becomes major product. Here also you will get product, but that P is minor. Are you able to understand the meaning of it now? Clearer? Right. Next, from alkynes, we have done preparation of alkyl halides from alkenes. Now we are discussing about alkynes. Same way on benzene also. For example, I will take one more example before writing that. Let me take that in this way. What is this called as styrene? Styrene. Response, sir. Styrene. If this is allowed to react with chlorine in presence of iron, then what happens? Electrophilic aromatic substitution. Correct, sir? So you will get chlorine either at ortho position or para position. Which is major? Para became major. Now, if it is allowed to react with chlorine in presence of carbon tetrachloride. Now, if it is allowed to react with chlorine in presence of carbon tetrachloride. Response, sir? What happened? First Cl plus will go and attack here on double bond to form 3-membered cyclic transition state. Then Cl minus will go and attack on other side. So product will be. I will write chlorine here and I will write another chlorine here. Correct, sir? Dichloroderivate. Say something. Yes or no? Now, in addition to that, if this is allowed to react with HBr in presence of peroxides. Now what happened? First Br radical will attack. Then I will get CH, CH2Br. I will get radical here. Response, sir? Right? Then is there any possibility for shifting this? Possible or not? Is there any possibility for this also?
Sir, can you slightly scroll and show the what's below allylic substitution, sir? Okay, sir.
Possible? Response, sir. If this bond shifts back, then it leads to formation of above product only. Na? You will get radical here that is same as this. Correct or not? So after getting a radical here, again this bond may come back to form this one. So these three are mutually interconvertible. So due to delocalization, what are the other possible products? What are the different possible products? One, H radical may come here. This is one possibility. Second, this possibility. Third, this possibility. Both are same, huh? No. So benzene's conjugation may be lost, may not be lost. Response, sir? No. Here, two such molecules can undergo dimerization. Two such molecules may undergo dimerization also. There is a bond formation between these two. Possible or not? Right? So there is possibility for dimerization products also. What we call this named reaction as? Bloomberg. I think it is Bloomberg reaction. Huh? No one is responding. Huh? Bloomberg, not Bloomberg. Huh? Bloomberg. What is happening? Or Bloomberg rearrangement of radicals. Correct only Bloomberg rearrangement reaction. Hmm. It is not a recognized term, it is saying. I will do one thing. Rearrangement of radicals forming biphenyls.
It is Gomberg's reaction.
Gomberg. Gomberg, not Bloomberg. Gomberg. Yes, sir. Right. Now perfect. Now perfect. Not Bloomberg, Gomberg. Right. It is not showing any radical mechanism. Huh? That's all. They have not given much. Where we can get then? ChatGPT, yeah? AI mode. It is thinking. Aryl coupling reaction. Two benzene rings, two phenyl rings couple with each other. Radical will form a bond. That's what they are saying. You're forming a new bond between two aryl groups, two aryl aromatic rings, right? Gomberg reactions may lead to formation of biphenyls also. So in that way, here also I may get other byproducts. So, but we are not much interested about, right? Anyhow, diazonium salts also N2 gas is gone, you will get carbocation, over which one electron comes to form a radical. Same method, right? So here I am writing what is the product I will write? Over alkene. Br goes to less substituted, right? Respond. Plus Gomberg products. But I am not interested on Gomberg products. Clear? This is enough for us. We are preparing alkyl halides now. Any other we have seen? If I add simply HBr, instead of adding this, if I add simply HBr, Marconi-Ka product, then what is the product? Means you will get bromine here. Respond, sir. Correct or not? No. Br2 in presence of H2O, then what you will get? Correct or? Respond, sir. Correct or not? But here another problem is there. One more problem is there. If we have good donating groups here, for example, groups like phenol or aniline, directly connected to benzene, in presence of bromine and H2O, product will be (2,4,6) tribromophenol. Right? Now there is possibility to form Br plus. Now Br plus can go and attack on benzene ring also. If a Br plus can go and attack, what type of group this is? Ortho para directing group. So Br plus can go and attack at ortho positions and para positions also. So other byproducts also possible, but we are not much interested about those byproducts as of now. In phenols, we will discuss that topic. Right? So as of now, I am not interested about the other byproducts. Clear? Any other? One more reaction, sir. Any other reaction you tell? Forming alkyl halides. Where that pi bond alone will interact, will interfere in the reaction. Say something. If I add HCl in presence of hydrogen peroxide, now what happened? Karash effect is not operate now. Means Marconi-Ka product is major. Respond. Any other questions? Right? Next, sir. From alkynes. Preparation of alkyl halides from alkynes. So this is third reaction, I think, right? From alkanes we have done. From alkenes we have done. Now we are seeing preparation of alkyl halides from alkyne. I am writing the reactions directly, sir. CH3, C triple bond CH. Allowed to react with HBr. Now tell me the product, sir. What happens? First H plus will go and attack. Right? Then Br minus will go and attack. So product will be CH3, C, Br, double bond, CH. Reaction will not stop there. It will again react with HBr to form CH3, C, Br, Br, CH3. Right? Because after adding this H plus, if we get positive charge on this carbon, if we have positive charge on this carbon, these halogens can donate their lone pair of electrons into that empty orbital. That enhances the stability of such carbocations. That's why generation of positive charge on the same carbon where electronegative atoms are present becomes stable. Right? If the same thing with Karash effect, anti-Markovnikov product. Now radical formation occurs. So in radical formation, such things are not possible. So instead of geminal, you will get vicinal dihalides now. Sorry. First step, what happened? Anti-Markovnikov product, correct? Response, sir? Okay, wow. So here we got geminal dihalides. Here we got vicinal dihalides in case of peroxides, in case of Karash effect, right? Next, sir. If same alkyne is allowed to react with Br2 in presence of CCl4. Now the products are. First one Br2 will be added, one above, one below, anti-addition. Another Br2 will be added. So totally 4. So we'll get CH3C, Br, Br, again C, bromine, bromine, CH3. Tetra halo derivatives you will get. Any questions? Respond. Do you have any questions in it?
No, sir.
After adding one, you will have second double bond also, na? Total 2 pi bonds. First pi bond is gone, we will add 2 bromines. Then what I will get? CH3, C, 1 Br above the plane, 1 Br below. Are anti-Markovnik, sorry, anti-addition, na? Friends. Reaction will not stop here because if you provide excess amount of Br2, reaction proceeds further. If you take only one equivalent, reaction will stop there. Right? But better I will do one thing then. What I will do is I will write Br, double bond. Again, I will add that Br2 in presence of CCl4. Done now? Response, sir. Here for allylic or benzylic, you write this one also. Halogens in presence of sunlight or halogens on strong heating. Halogens on strong heating also prefer allylic substitution if allylic carbon is available. This is allylic carbon. If allylic carbon is available, allylic substitution will prefer. Respond. Any questions up to here? Right? Now,
No, sir.
the first reaction of your target booklet. Preparation of alkyl halides from alcohols. Response, sir. That is your first reaction now from alcohols. Now, here you need to discuss about yes, 2 reactions. Grooves and Lucas test. Both. Right? Grooves reaction, Lucas test. Yes, but there also what we are getting as a product, chlorides, right? So in case of Lucas test, sir, what do you do? ZnCl2. HCl in presence of ZnCl2. One is Groove's method. Groove's process, which is nothing but preparation of alkyl halides. So our priority is to prepare alkyl halides. This is our motto here from alcohols. Another one is Lucas test. Here reaction may be same, but our motto is different. This is identification of Lucas test. To identify primary, secondary, tertiary alcohols, in which primary alcohols gives a turbidity only on heating or 20 to 30 minutes of time. Without heating, that's what I am. Forms turbidity only on heating. Either we have to wait it for 20 to 30 minutes time, means reaction is very slow, or I need to heat it. If I don't do it, there is no turbidity, right? That's why we will say primary alcohols will not form turbidity, right? Now, secondary alcohols, they form turbidity within 5 minutes. Approximately 5 minutes. Tertiary alcohols gives turbidity immediately. Right? In all the three cases, the turbidity is due to formation of alkyl halide only. Right? Due to formation of alkyl halide only, we are getting the turbid solution. Right? Now coming to Groove's process. Yes, sir. Now observe Groove's process. I am taking any alcohol or CH2OH in presence of HX, ZnCl2 lead to formation of RCH2X, Groove's process. What is the difference? Same only. But here my motto is to prepare alkyl halides. There my motto is to identify alcohol. Right? Now, mechanism. If I take HCl with ZnCl2, it forms ZnCl3 minus and H plus. Now, alcohol with H plus forms RCH2 OH2 plus, because this oxygen donated lone pair, right? This oxygen donated lone pair to H plus. RCH2OH2 plus. You got positive charge. Now from here H2O got eliminated. Then it leads to formation of RCH2 plus carbocation. On that carbocation, X minus or HX will attack to form RCH2X. Response, sir. Here if I take chlorine, I will write HCl. Any questions are in it? Response, sir. Right? Now, why in case of why Lucas test is different from here? See here. Here this in this reaction from alcohols we are preparing alkyl halides. Right? When I am studying Lucas reaction, same reagent I will take. Tertiary alcohols will form tertiary carbocations. And if it is tertiary alcohol, you will get tertiary carbocation. On the tertiary carbocation, you are getting halogen. So it is an example of SN1 mechanism. Right? So tertiary alcohols prefer to undergo SN1, whereas primary prefer SN2. Secondary generally prefers SN1 unless if there is any steric systems. Generally SN1 it prefers. Clear? So I am writing the same here. In Lucas test, if it is a primary secondary alcohol, sorry, if it is primary alcohol, reaction prefers to undergo SN2 mechanism. If it is either secondary or tertiary alcohol, then reaction prefers to undergo SN1 mechanism. Because in Lucas reagent or within Lucas test, there will be formation of formation of carbocations, whereas primary carbocations are unstable, therefore they will not be preferred to form. Here I have written the same, so it is not preferred to form. That's why I need to wait for 20 to 30 minutes in order to make the product. Clear? Response, sir. Any questions in it? Online.
No, sir.
Now I'm taking a
No,
note.
sir.
I'm taking a note. Sodium bromide allowed to react with H2SO4. Now what will be the product, sir? Sodium bromide with H2SO4. Sodium bisulfite plus HBr. Sulfuric acid is less volatile, so that's why it is used for preparation of more volatile products. Right? Less H2SO4. We have studied in sulfuric acid preparation properties. Sulfuric acid is oily, syrupy liquid. Right? It is less volatile liquid. Therefore, it is used in manufacturing of more volatile acids. Now, this HBr will react with ethyl alcohol. Then what will be the product, sir? C2H5Br plus H2O. Correct? Respond. Now, instead of bromide, if I take iodide, sir, sodium iodide I am taking, NaI, allowed to react with, here I will not prefer H2SO4. Reason? If I take H2SO4, obtained Hi will decompose to produce I2 because H2SO4 can act as an oxidizing agent. So in such case, we prefer phosphoric acid, H3PO4, lead to formation of NaH2PO4 plus Hi. Now, ethyl alcohol react with Hi to form C2H5I plus H2O. Reason, Hi gets oxidized by H2SO4 to form I2. That's why we don't prefer. Any questions in it? Response, sir. No questions now.
No, sir.
Now, this is one method, Groove's method, for preparation of alkyl halides from alcohols. Next method, sir, by using halides of phosphorus. Preparation of alkyl halides by using phosphorus halides. By using phosphorus halides, either PCl3 or PCl5. Here also reaction will proceed via what mechanism, sir? For example, I am taking ROH alcohol allowed to react with PCl3 to form RCl plus H3PO3. 3 times, so 3 OH groups. So I am writing 3, 3. Now, ROH with PCl5, RCl plus POCl3. What happens, sir? How the reaction proceeds? Observe this. ROH, phosphorus, chlorine, 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 and a lone pair. And also orbital is empty. Possible or not? Are phosphorus? D orbitals are empty now. Correct? Now, this oxygen can donate lone pair of electrons into that empty orbital of phosphorus. Possible? Possible or not? Then what you will get? R, O, one lone pair, positive charge, bond H, bond phosphorus, chlorine, 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 and you will get negative charge on this. Respond. Now, is there any possibility of removing H plus from here? Restoring the lone pair electrons of oxygen? Is it possible? Done or not? Then from here, can I remove Cl minus? Restoring the empty orbital of phosphorus? Is there any such possibility? Say something, yes or no? Or I will do one thing. I will do one transition state. R, O, H, positive charge, bond, phosphorus, bond chlorine, chlorine, chlorine. This is the thing generated, right? Response, sir. Now what I am doing is, already there is negative charge. I am making this bond to shift from here to here and making this bond to shift over oxygen. What you will get now? R bond Cl above phosphorus, bond OH, chlorine, chlorine. As chlorine gone out by taking the bond electrons, this orbital become empty. Now this negative charge, I have to write it as lone pair. Correct? From here, Cl is going out as Cl minus. Means this orbital becomes empty. This becomes empty means I should not write negative charge now. Now I have to write as lone pair. So what you got? One chlorine is replaced by one OH. If it repeats another 2 times, on phosphorus you will get totally 3 OH groups. And you will get 3 alkyl halides. Respond. Is there any possibility to form carbocation here or not? When this is gone, you get positive charge, carbocation is possible or not, right? So reaction, can I say, may proceed via SN1 mechanism. In case in place of OH, I am getting chlorine. So reaction may proceed via SN1. Similarly, with PCl5. Now, here we are not using PBr3 and PI3. Reason? Reason? PBr3 and PI3 are less stable. That's why we will not prefer PBr3 or PI3. Sir, if I want bromine here, then what I have to do? Bromine in presence of red phosphorus. If I want bromination, then I will do bromine in presence of red phosphorus or I2 in presence of red phosphorus. Right? Can be used for iodination and bromination. Response, sir? Any other questions in it? Next one, sir. Again, we are seeing preparation of alkyl halides from alcohols. Now, by using thionyl chloride, means SOCl2. Observe, sir. Thionyl chloride means I will write S double bond O, chlorine, chlorine. Now I am taking alcohol. Listen carefully, sir. Now oxygen can donate lone pair of electrons. So this oxygen is donating lone pair of electrons. This is shifted here. Then what you will get? R, O, H, positive charge. One lone pair is left. Bond, sulfur, O minus, Cl, Cl. Response, sir? Now observe here. Can I shift this bond back to oxygen? Now I am making this to shift here, making this Cl minus to come out. Now this H plus and Cl minus will combine to form. What you will get now? R, O, its a lone pair got restored. Bond sulfur, double bond O, chlorine. Plus HCl is lost. Response, sir. Any other questions? No. I am writing this in this way. Now I am doing rearrangement, making this bond to shift here, making this bond to shift here. What you got now? RCl plus SO2. Right? Now, OH is gone in one direction. Chlorine also coming in the same direction or not? Whichever direction OH is gone, chlorine is coming from the same direction or not? The direction in which O is breaking, R and O bond is breaking. In the same direction, R and chlorine bond is forming. Right? Means what happens to configuration? Remain same. If it is R, final product also will be R. So retention in configuration. We call this as Darjan's process. What we call it as? Darjan's process. I am writing the same, sir. ROH with SOCl2 forms RCl plus SO2 plus HCl. Now, do this rearrangement happen within the molecule or someone is coming from outside? That's why we call it as intramolecular nucleophilic substitution. Is it nucleophile or not? R minus, Cl minus. So nucleophile is replacing OH group within the molecule. That's why it is called intramolecular nucleophilic substitution. Now observe very carefully. If the same reaction is done in presence of pyridine, if the same reaction is done in presence of pyridine, then what happens? This HCl will react with pyridine to form pyridinium chloride. Right? Now free Cl minus is available. As a free Cl minus is available, instead of intramolecular rearrangement, instead of this rearrangement, observe what happens now. Now, instead of rearrangement, Cl minus will attack on one direction. Then this leaving group will leave from other direction. Now tell me what is the product? Observe, sir. Now what is the product? If I do the same reaction done separately, we got RCl plus SO2 plus that Cl minus got restored. Whatever Cl minus is attacking, that Cl minus is coming out as usual. Right? Now, incoming group and leaving group both are in opposite direction. So reaction is proceeding via SN2 mechanism. If there is no pyridine, reaction proceeded via intramolecular rearrangement SNI. If a pyridine is present, the same reaction is proceeded via SN2 mechanism. Understood? Any questions are in it? Respond. Online.
No, sir.
So I am removing this part. I will write that as a mechanism separately. Here the reaction will proceed via SNI mechanism. Intramolecular nucleophilic substitution. Right? So what happens first? First I am taking ROH in presence of SOCl2. In first step, HCl is lost to form ROS double bond O Cl. Correct, sir? Respond. Then what happened? Some sort of rearrangement leads to formation of RCl and SO2. Right? Now in this, what happened? Retention in configuration. Why I am writing retention in configuration, sir? Leaving group and incoming group are coming in the same direction. So in SNI mechanism, reaction proceeds via retention in configuration. Now, instead of SOCl2, I am taking SOCl2 in presence of pyridine. Same alcohol I am taking plus SOCl2 in presence of pyridine base. Now, sir, what happened? Now reaction will proceed via SN2 mechanism. Again, product remains same. Product remains RCl plus SO2. Response, sir. Response, sir. But what happens here? What may be the mechanism? First step is same. ROH with SOCl2. First loses HCl to form ROS double bond O Cl. This step is as usual. This step remains as usual. But this released HCl that will combine with pyridine that released HCl will combine with pyridine to form pyridinium chloride. Now, this obtained Cl minus will go and attack over R. Okay, wow. Will you understand if I write like this? Then you will get R. I am writing here in the other direction, sir, like this. Plus SO2. Of course, plus Cl minus comes out. Right? So in this case, what I am writing? Inversion in configuration. Response, sir? Cl minus is attacking from back side. Leaving group is moving from front side. If it is back side, it is moving in another direction, exactly 180-degree angle apart. Correct? So inversion in configuration. Any questions in this? Respond, respond. Now observe this case, sir. Same alcohol in presence of SOCl2 and any oxirane, right? Now observe the product, sir. Now inversion occurs 2 times. SN2 occurs 2 times. Observe this, man. Presence of this, right? So Dargen's reaction, right? Observe. First step, alcohol reacted with SOCl2, HCl is lost. First you got this one, right? If I am not adding anything, within the molecule rearrangement is there. This is going in one direction, in the same direction Cl minus is attacking. Within the molecule rearrangement happened. That's why it is called SNI, alkyl halide retention configuration. If I am adding pyridine, what pyridine is doing? In our example, what I have done? Pyridine I made to react with HCl. Then Cl minus become free. I made Cl minus to attack on backside. Right? If it attacks on backside, this bond will shift over here and this got shifted back. Pyridine got separated. Right? In our example, I kept pyridine as N plus as it is. Are you able to understand? Now what happened? Cl minus attacked from backside. So reaction proceeded via SN2. Now if I take oxygen, what happened? First, this oxygen donated lone pair from one direction. This opened up. This group is gone. Correct? Now Cl minus is attacking back. Again SN2. Configuration is retention. So 2 times inversion happened. Inversion and inversion leads to retention. Are you able to understand? Right? So I am taking the same example. In first step, what happened? First, there will be loss of HCl. There will be loss of HCl first. Then what you will get? R, O, S, double bond O, Cl. In first step, man. Correct? Huh? Right? Then what happened? After forming this. First step is this or not? Right? Next step, what we have done? We are making this to attack. We are making this to attack over alkyl group. If this attacks over alkyl group, then this bond will shift here and the Cl minus will be lost. Will you understand if I write like this? Instead of writing that, I am writing that here like this. Okay, ma? Now reaction proceeded by a SN2 mechanism. Then what I got? R O positive charge here plus SO2 plus Cl minus. Response, sir. Correct? Now, in next step, what happened? This obtained Cl minus attack back, making this to leave. Now, reaction proceeded via SN2 again. Correct or not? No need to write this. So, product will be RCl was restored. SO2 gone. This was restored. So, configuration is retention in configuration again. Any questions are in this? So inversion happened twice. Yes, I will give break, sir. Wait, sir. Go. Any questions about this one? Reaction with halogen chloride. Clear? So better I will stop here, sir. Go for break. Come back by 4:30. Already 4:20. Come back by 4:30. Online student join in the next link, sir. Online
Okay,
student
sir.
join in the next link.
Yes, sir.
வெளியே போட்டோம் காமிக்குது உள்ள போன இருக்கு
நீட் எக்ஸாம் எனக்கு படிக்கிறதுக்கா இதை பாரு இங்க பாரு ஸ்டார்டிங்ல என்ன அமைச்சிருக்கான்னு பாரு இதில் நீ வாய் பேசுற நாயே நீ வாய் பேசுற என்ன இன்ட்ரெஸ்ட் ஏன் காட்டு பேசுறியா தெரியாம அடிச்சுட்டு போட்டுருவாங்க
எப்படி கம்மி
இப்போ யார் யார் ஃபாலோ பண்ணாங்க
அது ஒரிஜினல் ஐடி கிடையாது. அது ஒரிஜினல் கிடையாது. ஒரிஜினல் ஐடி கிடையாது. எனக்கு வந்து தெரியாதா? இங்க பாரு இதெல்லாம் என்னது?
சைக்கிள் பொம்மை
Arey, still I am already 10 minutes late. Arey, do you know the meaning of pain? Just now I am feeling it. In up to my intermediate, my classmates, almost for everyone I used to teach either maths or physics, including Sanskrit also I taught to them, right? And finally I settled as faculty, right? These idiots who learned from me, few people, this is my group of my school and college mates. From class, I studied LKG, UKG, first class, same year I have studied. From there till my MSc second year, we had classmates, right? One gang, right? From left to right, everyone is my classmate only. Both are my classmates, both got married. Same place also, village also same. Both are my classmates, married. Both are my classmates, married. Both are classmates, married. All are my classmates only, right? I think yesterday they have some family get together at Dallas and they took one photo and they sent, right? Now I call it as pain. From that moment till now, I am doing the same job. Till now, I am teaching only. Huh? In that, one guy, that old guy is there now. He came along with me for studying MSc. Me and that guy, he looks old. Look to him properly, right? Right, man. Okay. We both has completed MSc. MSc is for 2 years. He studied MSc for 4 years. He invaded on exam centers to clear his MSc, right? Later, the moment on March 21st, I have completed my final exam. March 22nd, I reached home. 22nd night, I reached home. 23rd morning, the moment I woke up, my father made one dialogue. Because of that dialogue, 24th afternoon, I joined in a job as a faculty in my college only, where I have completed my BSc, Sadhana and Sodhriya College of Arts and Science, Madhiral. There I joined. From that moment till day, I am doing same job. Right? Places change, wings change, but same thing. This guy, 4 years he invaded. After that, for 2 years, he went into Bangalore. He has studied some something, .net something, right? Before that, not before Python, one thing came, man. No, before Java. C, C++, after that, 5. It looks like, it hurts like some fox or something like, something. He prepared for it, no jobs. Then he joined in Dell for a small thing, they removed. Again, he came back, again, he fought, nothing. Then through friends, my classmates, he went to US. There also he fight for 2 years. Finally, he got one small job. After 10 years, 15 years, his salary is 8 lakhs per month. right? Settled. He purchased his own bungalow there. Everything got settled. Now I am still doing the same thing. Immediately within one day, not even one day, I got a job. Right? Till I am fighting to have own house in India. He purchased his own here. That's why, sir, don't rush for getting settlement in life. Don't rush for it. Even if your parents feel that you are torturing them, let them face the trouble. You torture them, but settle properly. Don't rush. Learn. If it is taking time, again do it till you reach your goal. If you get compromised because of something, throughout life you have to fight. On that one day, if I have not reacted to my father, if I might have said, okay, and if I have continued for some more, I might have done PhD. I might have completed my PhD, and I might have gone through US or somewhere. At least if this is my profession, at least I might have settled as a professor in some good university there. Or life is different. See, in my case, I am saying my brother and sister, I realized the situation. My sister joined in MCA. After that MCA, she joined as a teacher. Literally for 2 years, we both had words war. I keep on demotivating her. Hey, waste, you are waste. She started teaching maths. Literally demotivated her. On one fine day, she got too much frustrated. She challenged me. I said, how many years you study? I will bear. She went to Bangalore. 3 years she prepared. And joined in HCL for small job. Then also I used to send money because her salary will not be sufficient, not even for rent. Right? She almost worked for 4 or 5 years there. Then she took a jump to Oracle. Now she got settled in Oracle. Right? Now I think she's a manager or team lead. I'm not perfectly clear about it. Settled. Her husband also, it is Accenture. He is also manager in Accenture. Both put together, they are getting 10 lakhs per month as salary. They got own house at Bangalore. My brother also, I have done the same. He completed BTech, electrical engineering. He joined in Trichy, BHEL, government job. I told you this. He joined in BHEL, government post it is. Because of one idiotic reason, he left. For that, he has to suffer for 4 years. There is no motivation in going to office. Right? What motivation you require? He left. He went to Bangalore. For 4 5 years, he struggled. Literally, I have scolded him. Maybe I might have hit him also. Because he's not getting any job. He's not taking things seriously. But later, first he joined in I forgot the name of it. Now he also settled as software engineer. Reasonably, he's getting around 2.5 lakhs per month. He's getting. Okay. Now he married another girl. She's also working in the same office. Both are earning reasonably good. Settled. But they struggled. That's what I'm saying. Right? So I rushed towards settlement. They have not worried because someone is there to take care. So that's why I'm saying to you seriously. Now this is the correct time, sir. At our time, at the time of 90 to 96, that is the boom for IT sector. Whoever entered, even a donkey gets a tag of software. The donkey also might have earned some 5 to 10 lakh rupees per month now. Literally, I'm saying that is the boom period. Now again, it is coming. By the time you come to the market, now you are in class 12th, another 4 5 years. In these 4-5 years, the total economics of the world is changing. This is the correct period. If you utilize this time perfectly, if you read properly, if you study things, understand things properly, if you get that skill, achieve that skill properly, you will get very good settlements. No need to look back. For another 2 to 3 generations, you will learn. You have that opportunity now. Right? So utilize this time more effectively. Take it seriously. Hardly 4-5 years if you work hard. Another 4-5 generations will get settled. After that, again, cycle will start. Right? So you have to be cautious. Right? It goes on. After seeing that picture, my peace of mind, everything is gone only. My uncle is there in US. You know KCP Fuller India Limited. It's Chennai only, no? It's office. KCP Fuller India Limited. Right? My mother's brother, Mama. He forced me like anything. You come first. I will book a flight. We will go. No, I said. Now he's not even calling me back. No one is even looking at me. Over. This profession, no, earlier it is a good profession. Now the charm of the profession is gone. Earlier people used to say teaching is the noble profession. Yes, it is noble profession for the people who are earning money, not for the teachers, not even for the students. The charm of the profession is gone. So earlier I not used to accept it. Now I am accepting. Only the people who fail in life will become teachers. Literally, I'm having that feeling now. After almost 18 years, 19 years of journey, now I am realized. Okay, that is failure only. That's why I became teacher. These are all, at that time, I felt them, they are failures. Hey, idiots, they don't know logic, what they will do. Now, they are successful. Right? So, take it, work for it. Right, sir? We will continue, sir. So, reaction of alcohols with the thionyl chloride to form alkyl chlorides. Now, I am taking one more example, sir. Sulfuryl chloride. Thionyl chloride means SOCl2. Sulfuryl chloride means SO2Cl2. Sulfuryl chloride, sir. Alcohols with SO2Cl2, sulfuryl chloride, in presence of sunlight and organic solvents. In presence of sunlight and organic peroxides. Organic peroxide means benzoyl peroxide, right? Peracetic acid, etc. Forms RCl plus SO2 plus HCl. Right, sir? Oh, 1 minute, 1 minute, 1 minute, 1 minute, 1 minute. It should be alkane, sir, not alcohol. Alkane, sir. HCl, SO2, RCl. Preparation of alkyl halides from alkanes by using sulfuryl chloride. Right? Next, sir, we are done with preparation of alkyl halides from alcohols. Next, from aldehydes and ketones, we will discuss it as a separate reaction because few named reactions are there. So we will discuss that separately. So aldehydes and ketones, I am not discussing now. Next, preparation of alkyl halides from carboxylic acids or from salts of carboxylic acids. So from silver salts of fatty acids. Once open your target booklet, whether we have discussed all preparations of alkyl halides or not. Check, sir. Check, have you done or not? Preparation of alkyl halides. In page number 71, first it is there from alcohols, right? By reaction with halogen acids, means by adding HCl or HBr. Next, by action of phosphorus halides, PCl3, TCl5. Then by action of thionyl chloride, means by using SOCl2. Then from hydrocarbons, means preparation of alkyl halides from alkanes. From alkenes, done. Next, from alkynes. Then halogen exchange. Already we have done Finkelstein reaction, Schwarz reaction. Then halogen exchange only. So that part also done. Now see that page number 76, knowledge crowd. What is the knowledge crowd? Preparation of alkyl halides from carboxylic acid, silver salts of fatty acids, right? So from silver salts of fatty acids, sir. Here two named reactions, sir. One is Borodin-Hunsdijker reaction. Second one, Bergman-Simonini reaction. Two named reactions, right? Borodin-Hunsdijker and Bergman-Simonini. Observe this one. I am taking some silver salt of fatty acid. Allowed to react with halogens in 1:1 molar ratio. In 1:1 molar ratio. In presence of carbon tetrachloride, non-polar solvent. Right? Then you will get RCl. Here I am taking X2 because I can take bromine chlorine also. So RX plus CO2 plus AgX. Right? In this, primary halides react more readily than secondary halides react more readily than tertiary halides. Primary, secondary, tertiary. We call this reaction as Borodin-Hunsdijker reaction. Right? So this is best to prepare alkyl chlorides and alkyl bromides, right? Now, sir. How this reaction occurs? Listen first. Please. Listen, sir. So first Ag plus and X minus, no? AgX is gone. So what do you get? So I am writing R, CO, O, X. Correct or not? This later may convert into RCOX also. Later it will convert into RX. Now when you take this ROX bond, that OX bond, in that OX bond, they have given any mechanism. Once check the mechanism. What they give? Radical mechanism. Correct one. RCOO BR. Correct or not? RCOO BR. Correct only, no? RCOOX. Right? So first AgX is gone. So I will write that same mechanism also. Mechanism. Formation of RCOOX bond breaks down to form RCOO radical, X radical. Correct, sir? Next step, we are getting R radical. Check. RCOO radical gives rise to R radical plus CO2. Now this R radical combined with X radical to form Rx. Correct or not? Correct only, na? No. In this, we are having O-Br bond. You will get O-Br bond. Same way O-Cl bond also, right? So O-Br bond is weaker than OCl bond. And at the same time, AgBr is less soluble in water than AgCl. That's why if this O-Br bond breaks readily means R radical will be formed readily, means Rx will be formed readily. That means among chlorine, bromine, which is more reactive for carbon sorry, borodine Hinsteicher. So Br2 is more reactive than Cl2. Are you able to understand? This RO-Br bond is weak. Therefore, it will break readily. And here we are getting AgX also, na? AgX is also not soluble in water. AgBr is not soluble in water. So it will not create ions. So reaction moves in forward direction always. This is getting precipitated means this reaction always moves in forward direction. Correct or not? That's why bromination will occur more readily than chlorination. Right? If the same reaction is done with iodine, if the same reaction is done with iodine, RCO, O minus, Ag plus, plus I2. If I take this in 2:1 molar ratio, same solvent. CCl4 followed by heating. You will get RCOOR plus AgI plus CO2 also, because I am taking 2 moles. And first what happens? You will get RCOO radical plus I radical, correct? All right, I will do one thing. First, let me write this. First, AgI is gone. After AgI, what you will get? Correct? This bond is weak, so it will break down readily to form. This will combine with R radical to form. Correct? To form Ri. R radical plus I radical will form Ri, CO2 is gone. Correct or not? Now, another COO minus will attack over it. Second, we have taken 2 moles. Na? First mole happened in this way. Second mole can attack here. Then what you will get? RCO OR. Here Ag plus and this I minus will combine to form AgI. Correct? Response, sir. Any questions in it? So you got ester. If I take 2:1 molar ratio of silver salt of fatty acid and iodine, we call this reaction as Berbon-Simonini reaction. Right? So we are done with preparation of alkyl halides from alkanes, alkenes, alkynes, alcohols, fatty acids. Then properties, sir. Regarding properties. First, regarding physical properties. Check your target booklet, sir, regarding physical properties. First, they have talked about melting point, boiling point, and solubility, right? So see the first point. Lower alkyl halides, such as methyl fluoride, chloride, bromide, ethyl fluoride, ethyl chloride, all are gases at room temperature. All are gases at room temperature. Methyl iodide, iodine molecular weight is high. Methyl iodide and carbon chain up to C18. Alkyl halides up to 18 membered carbons. All these are colorless, sweet smelling liquids. Above them are all solids. Now, most of the alkyl halides will have higher boiling points than respective alkanes. Means methyl fluoride have boiling point higher than methane, than parent alkanes. If you take boiling point order, which have heavier molecular weight, iodides, right? If they have same number of carbons, means if carbon chain length is same, then corresponding alkyl iodides boiling point greater than, bromides greater than, chlorides greater than, fluorides. Reason? Molecular weight. If you take isomers, respective boiling point of isomers, means all are chlorides only I am considering, right? 4 carbons, 1 chlorine. Then what happens? We can rearrange now structural isomers we can create. Correct or not? These two are isomers or not? So isomers boiling point we are comparing. Then as chain length increases, what happens? Surface area increases. If chain length increases, surface area increases. Then van der Waals interactions increases. Then it is difficult to separate them. Therefore, boiling point increases. So as chain length increases, boiling point increases. So primary alkyl halides generally will have higher boiling points than secondary than tertiary. Next, point number 3. Density. Alkyl fluorides and alkyl chlorides are generally lighter than water. So density less than water. Alkyl bromides and iodides are heavier than water regarding density. If you want to compare, iodides have more density than bromides, more than chlorides, more than water, more than fluorides. Means generally all alkyl fluorides have, methyl fluoride have less denser than water. Fluoride is almost close to water. And if density of water is considered as 1, this may be 1.1. Not much deviation, right? Very close to each other. CCl4 density is greater than CHCl3, greater than CH2Cl2, greater than H2O, greater than CH3F. What I have done? Yeah, till now, chlorines I am comparing. Actually, what I have to write here? I have to write CH3Cl. Already I wrote now, right? That's why all these are denser than water, right? CH3F is less denser than. So I am removing this also. Problem solved. Right? Next. Alkyl halides. I am talking about solubility now. We are done with physical phase, boiling points, density. Now we are talking about solubility. Alkyl halides cannot form hydrogen bonding. Therefore, they are not able to form hydrogen bonding. Therefore, almost insoluble in water. Yes, sir. More electron into atom, then also it will not form. Reason, for example, if I take CH3Cl, chlorine have lone pair of electrons. Now I am taking water. Hydrogen get partial positive. What is hydrogen bonding? Interaction between hydrogen which is present on more electron into atom and lone pair of electrons of more electron atom. We call this as hydrogen bonding, na? But problem is this group is there, na? This group always repel water. So this group will never allow water molecule approach halogens. Will never. Because here hydrogen is not on more electron atom. So for condition is hydrogen should be present on more electron atom and lone pair of more electron atom should have interaction. That is called hydrogen bond. Right? Because of this group, water will never approach it. If it doesn't approach it, distance increases. If distance increases, bond weakens. So there is no hydrogen bonding formation. Right? Next, sir. If you remember, ortho meta para dichlorobenzenes, melting point, boiling point, already we have seen. What's that?
Sir.
Right? Ortho dichloro, meta dichloro, para dichloro. Melting point order, which is having higher melting point. Para greater than, meta greater than. Melting point or boiling point? Online. If it is boiling point, ortho greater than, para greater than, meta, they have given on table, check. So ortho greater than, para greater than, meta. If it is melting point, I need to exchange ortho and para. Correct or not? So para greater than, ortho greater than, meta. In both cases, meta is lowest. Check, check. Yes or no?
Yes, sir.
Next. Point number 5. Identification test. To identify alkyl halides, already in class 11th we have seen Lezane's extract. A given organic compound was taken in a test tube. We'll add, first we will take a dry test tube, not test tube, ignition tube. In that, we'll take a small piece of sodium metal. We'll keep that in flame so that sodium doesn't catch fire. Right? Then we will cool it. Then we'll add a drop of given organic compound. Again, we will heat it vigorously such that organic compound should not catch fire to red hotness. Then we will plunge it in a beaker of water. We'll break it, boil it, filter it. That liquid is called Lezane's extract. Now take a drop of that Lezane's extract and add silver nitrate. If we are able to get white PPT, which is soluble in ammonium hydroxide, chloride, yellow PPT, sparingly soluble in ammonium hydroxide, bromide, yellow PPT, insoluble in silver nitrate, iodide, right? Lezane's extract test, already we have seen. Now one more test we are seeing, Weldstein test. When alkyl halides are heated over a copper wire, generally if you keep a copper wire in flame, you will get greenish color, apple green color, right? So alkyl halide burn with green flame over copper metal. Listen here, man. That's what I am shouting. If you want to become teacher like me, you make noise. If you want to enjoy and send photos like that in WhatsApp group, then listen to class properly and study. Right. Rx burn with green flame over copper wire. We call this test as Feldstein test. This Feldstein test is not reliable test. Reason, is not reliable test. Reason, we cannot identify what type of alkyl halide it is. For every alkyl halide, it gives almost a similar color, right? So it cannot identify which halogen. But we can say halogens are present, that's all. To identify which halogen is present, which is best reagent, best test, Lezine's test. Next. By using this test, we cannot identify fluorides. To identify fluorides, best test is to identify fluorides. In Lezine's test, you will get sodium fluoride as a solution. In all Lezine's test, that final Lezine's reagent is nothing but sodium salts. No? If fluorine is present, sodium fluoride is present. Then if you add sulfuric acid or HNO3, you will get HF. Then you add some amount of sand, silicon dioxide. Silicon dioxide with HF forms H2SiO3, turbid gelatin solution. If you add a drop of NaOH, sodium silicate, NaSiO3. Then if you add a drop of any colored salt, you will get silica gardens. Conforms fluoride. HF has the ability to dissolve silicon dioxide. We call it as etching of glass to give designs on the surface of glass. Respond. So it cannot identify fluorides. Another problem with Feldstein test is test will be positive even in absence of halogens. Use positive test with pyridine. In pyridine, there is no halogen. Urea, thiourea. Thiourea means? Correct, sir? So with urea, thiourea, pyridine also test will be positive. Right? Physical properties. Any questions, sir, in this? Now, regarding chemical properties. Before going to chemical properties, I will do one thing. Two named reactions we missed, man. So let me write this as, okay, no issue. Here you continue. Preparation of aryl halides. Till now we prepared alkyl halides. We have not prepared halogens on benzene, right? So preparation of aryl halides. In that first reaction, electrophilic aromatic substitution reactions. No need to discuss. Electrophilic aromatic substitution reactions. Attack on benzene ring, right? So electrophilic aromatic substitution reactions. Now, benzene is allowed to react with halogens in presence of, for example, if I take bromine in presence of FeBr3, which acts as catalyst and it is a Lewis base, correct? Lewis base or Lewis acid? Lewis acid. And empty orbital is there. So Lewis acid. For example, ZnCl2 also Lewis acid, AlCl3 also Lewis acid, etc. Right? Now, instead of that, you can use AlCl3 or ZnCl2. Or directly I can use iron also, because some amount of iron can combine with Br2 to form FeBr3. Right? Then what you will get? You will get bromine on plus HBr. Response, sir. Electrophilic aromatic. Is it necessary to discuss about mechanism? No need now. First Br2 will combine with FeBr3 to form FeBr4 minus and Br plus. Br plus will go on attack on benzene ring to form bromobenzene. Correct or not? Intermediate is called Wieland intermediate or sigma complex or arenium ion. Say something, sir. I will do one thing. In a short form, I will write Br2 plus FeBr3 gives rise to FeBr4 minus and Br plus. Second step, Br plus will go and attack on benzene to form bromine. You will have positive charge on all carbons except that carbon. On that carbon, you will not get positive charge. Right? Delocalization. This positive charge undergo delocalization on remaining carbons. We call this intermediate as sigma complex, or we call it as Wieland intermediate. Correct? Online. Already few people left. Wieland
Yes, sir.
intermediate, arenium ion. Now, after this, from this carbon, hydrogen gets abstracted by FeBr4 minus. This pulls that H plus out. If H plus is out, this bond will shift back to form aromatic ring. Correct or not? So next step, I am writing this in this way. H, Br. I am taking positive charge here, or I will take positive charge on the other side. Positive charge, bond, bond. Now this FeBr4 minus will abstract H plus, then this bond will shift back, lead to formation of aromatic ring got restored, correct? That FeBr3 will be formed, plus HBr is generated. So FeBr3 involved in the reaction finally regenerated. Therefore, it acts as a catalyst. Respond, sir. Any questions in it? Online?
No, sir.
Right? No.
No, sir.
This is one reaction, one example. I am taking one more example, sir. On benzene, if you have CH3 group, what type of group this is? Electron donating group. Electron donating group. Or can I say it as ring activating group? And whichever gives electrons into the ring is called ring activating group. Or we also call it as ortho-para-directing group. Correct? Now, if this is allowed to react with, Br2 in presence of iron or FeBr3, what happens now? You will get bromine at either ortho position or para position. Which is major? Para bromo will be major. If you have a withdrawing group, then meta will be major. I am taking one more example. I am taking ethyl benzene I am taking. Allowed to react with Br2 in presence of iron. Now tell the product, sir. Then also para bromo will be major. Response, sir. Now if I consider, respond, please, listen. I am taking different products, sir. Ethyl, isopropyl, tertiary butyl. Now, among these four, which will react towards electrophile more readily? Among these four, which will react more readily? First one, reason. This is sp2 carbon. Next carbon is alpha carbon. Hydrogens of alpha carbon involved in hyperconjugation. Therefore, they will increase electron density here. Remaining here, if you take tertiary butyl, there is no alpha hydrogen. Only it shows inductive effect. Right? Compared to inductive effect, hyperconjugation is always dominative. So, which will increase electron density inside benzene ring? Towards electrophilic substitution. Response, sir. Now I am taking one more example. Now it is allowed to react with bromine in presence of sunlight, sir. I am not adding catalyst. Without adding catalyst, just bromine on heating or bromine in presence of sunlight. Or N-bromosuccinamide. Then what happens? Allylic substitution or benzylic substitution happens. Now that radicals will go and attack on carbon, not on benzene ring. So product will be. Are you able to understand? Clear? Radical mechanism. It is not electrophilic substitution. It is radical substitution. Respond, sir.
Yes, sir.
Respond. Any other questions? Of course, you may get other byproducts also. Sir, radical substitution means this will be major. Some other byproducts also will be there, no? You may get the bromine here, right? If it is monobromination, then you may have dibromination, tribromination. Totally, 5 hydrogens can be replaced by 5 bromines. And radical substitution yield will be always very low. Correct? So I will write this plus many other products. Right, sir? Any other questions in it? Now, second
No, sir.
reaction, sir. Via diazonium salts from benzene diazonium salts. From benzene diazonium salts, right? Now say this. Okay, I will stop discussion. We'll see later. Next time I will take first hours only. Last hours, you are asking break on the top at 5:30. Before 5:30 itself, you are expecting. Now it is 5:28 only. Right, sir? Online students, you can leave. Plan for this thing. I told you to mentally prepare for. After 16, I think 16th is Saturday. So 16th is Saturday means your regular class only. No need. 17 also as usual. No need. So 18th, 19th, 21st, 22nd means hardly you will attend 8 more classes extra. Right? The moment September comes, na, September, October completely vanish in holidays only. Diwali vacation, Dasara vacation, Ganesh Chaturthi. When? August 27 Wednesday. Okay, take, no issue. Right? I am requesting before Dasara vacation, we need to close the syllabus. At least 90-95% of syllabus we need to close. Right? For that, one push is required. So for 2 weeks, not more than that. For 2 weeks, try to come on weekday as well as weekend also. Right? Hardly 8 additional days. You will come regularly. 8 additional days. Okay, wow. Weekday and weekend also. Right? Mentally prepare for it, plan for it. Right? Online students, you can leave. I will give you your attendance by downloading. You can. 15th. I am ready, but our people are saying that. Listen. Shh. Earlier, things are used to be okay. I think because of some incident happened at Delhi, not in Akash, somewhere. If you want to conduct classes, any special classes, you need to get a permission letter from district collector. Who will go there? Who will bring it? Right? So that's why no extraordinary classes, only ordinary classes. Okay, wa? Right. Now, online students, you can leave, sir. Bye, sir.
Thank
Good
you,
night,
sir.
sir.
Thank
Offline
you,
students,
sir.
wait, attendance. Yes, sir. Bye, sir.